Hello, everybody, and welcome to the second session of CosmoVerse's Journal Club. Our today's first speaker is Masoume Reyhani, and she's currently a master's student at Khaja Nasser University of Technology and is studying on nature of dark energy and dark matter. Today, she's going to talk about her work on structure formation in various dynamical dark energy scenarios. And Masoume, the stage is yours.
Thank you, Mahdi. First, I really appreciate this opportunity to be here among you, dear ones. And thanks a lot, CosmoVerse team, to hold these meetings. The topic of what I'm gonna speak about is a structure formation in various dynamical dark energy, which is this article has written by me and colleague and has published in this journal by this link. By the way, I'm Masoume Reyhani. Happy I'm here. The general view of what I'm going to talk about is here. First, we know that our universe needs to be described by a model. Lambda CDM is a largely compatible one which can describe our universe. The Lambda CDM is a compatible one which can describe the universe very well with what we comprehend from the events. There are some tensions in Lambda CDM model which motivated us to think about alternative models such as dynamical dark energy models. It motivated us to study the effect of dark energy on a structure formation via studying matter power spectrum and ISW effect. Because as we know, the ISW effect is getting more important in larger scales, so we can see the nature of dark energy and its effect on ISW very well, so we studied it. Let's have a view on Lambda CDM model. As we know, Lambda CDM, considering the universe to be homogeneous and isotropic, and Einstein have related the geometry of this universe to its matter as this equation, and by writing the line element for this universe and actually the Friedmann equation we have here, we can see that for equation of a state which relating the pressure of component of the universe to their density, we can see that for Lambda CDM model, it's constant and it's equal to -1. And for Friedmann equation, we can see the density parameter is not changing by changing the scale factor, and it's constant. But what we're gonna talk about is the dynamical dark energy that the equation of a state and also the parameter density parameter will change by a scale factor. Why Lambda CDM is a success model? As we know, Lambda CDM describing the universe only with 6 free parameters, which is very good. And by plotting the temperature, cosmic microwave background temperature power spectrum for Lambda CDM model and getting data set from Planck, we can see a good fit and good match. Which is tell us that Lambda CDM is working very well and is matched to our observatory. But what is a problem with Lambda CDM? As we know, there are some tensions in Lambda CDM model that we know them. One of the most important one is Hubble tension. And it's about 4.5 sigma standard deviation, which is a discrepancy between the direct and indirect measurement of the Hubble constant. And the other tension is the tension in amplitude of late time matter clustering, which we call it sigmoid or S8. In the wake of this cosmological tension, we think about other alternative models and new physics to describe our universe better. People introduced the dynamical dark energy models, and we use these three dynamical dark energy models, CPL, JBP, and BA, at our study. That, as you can see, the dark energy equation of a state is varying by a scale factor, and they're not constant as wCDM or Lambda CDM anymore. And in this study, this article has shown that by using these dynamical dark energy models and actually using the Planck only data sets, or a combination of Planck with BAO or Schu's data set, we can see for Planck only and its combination with Schu's data, we have increase in H null, and the H null tension has alleviated. So it motivated us to use these models to study the ISW, and the combination of that article with other article that studied the ISW effect, which in this article the result have shown that the nature of dark energy and dark matter have affected on ISW effect. So ISW effect would be a proper tool to study the dark energy. It motivated us to study the structure formation by using matter power spectrum and ISW effect in these dynamical dark energy scenarios. Okay, from here on, I will talk about what we have studied in our paper. But first, let me explain a little about what ISW effect is. As you can observe here, the ISW effect focuses on the change of wavelengths of cosmic microwave backgrounds photon. As you can, it can be seen, the photons which are coming from the last scattering surface to us by when enter a potential wells, they will experience a decrease in their wavelengths, and by moving out from these potential wells, they will be redshifted. But by expansion of the universe, we can see that we can see a decrease in depth of these potential wells. So the original wavelengths of these photons, it's not as same as the final wavelengths. So it can be a good tool to study the potential wells that are on the way of photons which are coming from the last scattering surface to us. To study the ISW effect, at first we need to study the matter power spectrum and the evolution of ISW source. So here we have plotted the matter power spectrum in two different redshifts, z equal to 0 and z equal to 1. As depicted here, regardless of the chosen models, we can see for all models by moving toward higher redshifts, we can see a decrease in the amplitude of all models. The dotted line depicts the z equal to 5. And as can be observed, regardless of the chosen redshift, in this tree panel, we can see that dynamical dark energy BA, JBP, and CPL has a higher amplitude compared to constant models wCDM and Lambda CDM1. that it can be a footprint of dark energy on a matter power spectrum. And we can see impressive feature is that by moving toward lower k or larger scale, we can see that a shift to larger scale for baryon Wigel peaks, for especially for BA and JBP in comparison with a constant one, but for a CPL is not as noticeable as two other cases. Then we have the evolution of the ISW source and its derivation as a function of a scale factor. This panel demonstrates the evolution of the ISW source as a function of a scale factor, as it can be seen here. For all dynamical dark energy models have suppressed in comparison with constant one. And by moving toward scales that dark energy become the dominant force of the universe, we can see a rapid increase in all amplitude of the models. And the right panel illustrates the evolution of derivation of the evolution of ISW source. And it shows that for a Lambda CDM model, there is the most extreme change for a Lambda CDM model. And there is at the scale factor almost 0.6 till 0.65. We can see a change in a strength of the BA and JBP model, as well as CPL and wCDM model. So now we can talk about the ISW effect that we have studied it via ISW auto power spectrum and ISW cross power spectrum. Here we have ISW auto power spectrum, which study the obtained result from the correlation between from the temperature correlation between the cosmic microwave background photons, as we can see here in this formulation. And we have plotted the results here. As you can see, by moving toward higher Ls, we can see a decrease in all amplitude of all models. And as you can see, the JBP and BA has dominated over other three cases. And interestingly, we can see that wCDM, which is a constant one, is dominates over a CPL model. And also, but moving toward larger L, we can see that Lambda CDM is rising over CPL model too. The last panels is the ISW belong to ISW cross power spectrum. Here, as you can see, we have depicted the ISW cross power spectrum in 4 different panels for 4 different surveys, such as DUN, Euclid-like, SDSS, and NBSS. As you know, ISW cross power spectrum is studying the ISW temperature and isotropy correlation between ISW temperature and isotropy by the larger scale structure such as galaxies. In 3 of these surveys, DUN, Euclid-like, and NVSS, we can see that they have almost same behavior. In all of them, we can see that JBP and BA are dominate over the other models. And we can see a challenge between wCDM and CPL models, that by moving toward larger Ls, the wCDM model is rising over CPL, and in some cases, we can see rising over BA2. But for SDSS model survey, by choosing SDSS, we can see a little different behavior. As we can see here, all dynamical dark energy are dominant or are higher in amplitude compared to constant one, and it's a little hard to discriminate between JBP and BA, especially at a lower L. And you can see that for all cases, the wCDM model is subdominant in terms of the strength of ISW power spectrum. Here we have the conclusion. Let me just summarize what we have talked about. We studied the structure formation by studying ISW effect and matter power spectrum. We studied matter power spectrum in two different redshifts that we saw that for higher redshifts, we can see the decrease in the amplitude. That means that by moving toward a current age of the universe, we have more a stronger structure formation. So by studying the ISW via studying ISW auto power spectrum and ISW cross power spectrum, we could see that in ISW auto power spectrum, the JBP and BA model are dominate over the other two cases, but for a wCDM model, we have shift in wCDM model is upper in value compared to CPL1. And we have investigated the ISW cross power spectrum in 4 different surveys, and we saw an almost same behavior for 3 of them, Dune, Euclid-like, and NVSS, but a little different by choosing SDSS survey. That in SDSS survey, we could see that dynamical dark energy, all dynamical dark energy models are have higher values compared to the constant one. Here we have some potential for future study. In this study, in this paper, we have studied the linear approximation for matter power spectrum, but it can be good and it can be informative to study also the nonlinear approximation. And also by using a different dataset combination for matter power spectrum, maybe we can see the different behavior. So it can be informative to a study too. And at last, thank you for your attention.